Hello everyone, my name is Wei Wu.
My name is Yuan.
Welcome to this presentation for our air pollution cost analysis submission for the IBM Boston Analytics Global Competition 2017. And we are presenting on behalf of our team from the University of Texas at Dallas. Air quality is an important issue related to our health. Our analysis is to figure out the construction of air pollution and the causes of this pollution, and finally find the relationship between air pollution and their causes using IBM Watson Analytics tool.
First, let's see data source. Through researching, we think air pollution consists of nitrogen dioxide, carbon monoxide, sulfur dioxide, and ozone. We assume air pollution affected by four factors. They are called population, vehicle, and production value of manufacture. Pollutants data is from United States Environment Protection Agency website. Coal consumption is from U.S. Energy Information Administration website. Pollution is from United States Census Bureau website. Production value of manufacture is from Federal Reserve Economic Data website. Vehicle is from Bureau of Transportation Statistics website. Next, let's see the dashboard. Let's have a look at the trend of carbon monoxide discharge over a year from 2000 to 2016. As you can see in this line picture, the discharge of carbon monoxide slightly goes down among years. This may result from the improvement of the technologies of coal washing and coal combustion. What's more, the development of clean energy also reduces the need of coal, which will eventually decrease the carbon monoxide discharge.
For details of the consumption of coal for all the states, we generated a breakdown graph. Every square represents a state. The area of the square and the darkness of the color are positively correlated to the consumption of the coal. Regarding to the graph, the Texas consumes the most coal every year, followed with Illinois and Indiana. The first 8 states consume nearly half the whole of the University of State. Another factor of air pollution is the liquid waste and exhaust gas of manufacture. Here, we use production value of manufacture to represent them. We use stacked area chart to describe the trend of production value of manufacture. As a whole, the production value increases over years with a little drop in 2009. Different colors represent the contribution of production value of different states.
Based on this picture, we can directly see that darker states, which represents much more vehicle in the states, are focused on California, Texas, Florida, and some northeastern states like New York. Similarly, in the word cloud showing population level, California, Texas, Florida, and New York are still the bigger ones. That's reasonable because the more people in the state, the more vehicle needed.
Now let's see the relationship between causes and different pollution gas. From this picture, we see the larger the bubble is, the more manufacturer production value is. And the darker the area of state is, the higher the nitrogen dioxide level is. We can see big bubbles mostly located like California, Texas, and some states in the northeast, where the color are darker than others as well. So we can infer that the manufacturer production value keeps a relatively positive relationship with the nitrogen dioxide level. Additionally, due to the need of manufacturer, energy such as coal, oil, and gas needs to be consumed and burnt, which will greatly lead to the emission of nitrogen dioxide. From the combination chart on the right, we can see a clear relationship between vehicle and sulfur dioxide. The line is the value of sulfur dioxide. The column is the number of vehicles registered in the state. We have an obvious move pattern by state. The larger the amount of vehicle, the higher value of sulfur dioxide. According to researchers and referring to the data pattern, we can conclude that one possible cause of sulfur dioxide is vehicle exhaust. Finally, let's see, this graph is about the relationship between nitrogen dioxide and the carbon monoxide. there is a positive relationship between these two values. So we can see they may come at the same time. So maybe there will be some activities such as manufacture or vehicle will create both of these two harmful air pollutants.
Let's come to our insight. In conclusion, first, there exists an obvious correlation between these human activities and air pollution conditions. Second, within these harmful air pollutants, they tend to show up at the same time and in similar patterns, from which we can infer that some human activities will create multiple hazardous air pollutants. Third, the number of vehicles and pollutants have a positive relationship. Therefore, with the number of vehicles increasing, we have to try to use clean automobile fuel to decrease pollutants. We hope that you enjoy the presentation and sincerely appreciate your time and consideration. Thank you.